Alright, so after we've done our introduction to quadratics, here's now our intricate details on how to graph quadratics. Starting off, let's just look at some graphs here. Let's pinpoint some information that are going to help us in the future when we're actually graphing on our own. So the ideas that we want to find from these three graphs, we want to find its maximum or minimum. So we're going to just call that the vertex right now. The axis of symmetry, and the roots. And remember, we have a couple words that mean the same thing. So roots, those are your solutions. Those are also called your x-intercepts. And they're also called your zeros. So whenever you see any of those words, it all means the same thing. And personally, I always just try to think of x-intercepts because they, they're the ones that you know the most. So let's zoom in on this first graph over here. First thing I want to do is to find the vertex. So I can see it's at the highest point, which is right here. My vertex, I'm going to count that point. So it's going to be -2, 1, 2, 3. So -2, 3 is going to be my vertex. Okay, now let's find our axis of symmetry. So we can just shorten that to AOS for axis of symmetry. Now that is going to share the same x value as our vertex. And the reason why is that our vertex is in the very center of our parabola, and so is our axis of symmetry. It cuts it right in half. When we're writing our axis of symmetry out, it's always x equals, and then the value that it's at -2. So whenever you see something written like this, that's telling us it's a vertical line. So vertical line at x equals -2. Okay, x equals is always just vertical. Now the last thing that they're asking is for our solutions, or our zeros, or our roots, x-intercepts. Remember, they all mean the same thing. X-intercepts are the easiest things to remember. So my first solution is going to be at 0. And then I have another one over here, which is -4. So I'm just going to write this as solutions. And I'm just going to write out our two values here. So we had -4 and 0. And it's as simple as that to find this information. Let's look at the next one. Okay, so ignore the writing from our last problem. So the first thing we have is our vertex. Our vertex is right here at 0, 0. So our vertex is at 0, 0. Now, with our axis of symmetry, you can see that if our vertex is at 0, 0, our axis of symmetry is going to share that same x value because it's cutting the parabola in half. So our axis of symmetry, that's going to be the vertical line, x equals 0. That's where that line hits on the x-axis. Now the last one's a little tricky for this problem. If you think about where we're hitting the x-axis, this one will only hit it one time, okay? And that one time it hits the x-axis is at the value of 0. So our one and only solution will be 0. Now I know this seems like nothing, right? Because I just basically said all zeros. But this is valid information, and this would get you full credit on a problem. Last one. So when we're looking at this last one, let's find our vertex first. So vertex that I see that it's at 3, because I went over 1, 2, 3, and then down, and we had to go down 1, 2, 3, 4. This one's a little hard because there's no values here. So this is the point 3, -4, because I had to go down. I'm going to erase these little curly cues here, get them out of the way. And then we need to find our axis of symmetry. It's just that vertical line that cuts right through the parabola. And you can see that it hits the x-axis at 3. So that means this is our vertex, our axis of symmetry. Remember, it's going to share that same x value, so it's going to be x equals 3. If you write that it doesn't, that's like the first indication that maybe your answer is not correct. Your x value of your vertex, x value of your axis of symmetry should be the same. And then our last thing we want to find are our solutions. So here's one, here's another, and we just have to write the values here. So our solutions. Okay, the first one I see is 1, and the second one I see 2, 3, 4, 5. So 1 and 5. Okay, we do have two different forms, actually 3 different forms that we can write our quadratic equations in. Our first form is our vertex form. Okay, vertex form lets you find the vertex very easily. Okay, in vertex form, when we look, you see that you have an H and a K. Those two values, those are your vertex. So this is something, this whole page and this whole presentation, you definitely want to be writing this down because the different forms will help you when you're graphing in a different way. So our vertex form, that means that you can find H and K. Now the big thing is to remember that right here, you have a minus H. When you have a minus H, that means that whatever you really see, H is the opposite, okay? So HK, and then we've talked about this many times. So whatever the x value of the vertex is, that's what your axis of symmetry is. So another form that you might see is intercept form. In intercept form, you can see P and Q right here. Whatever values you see here, those are going to be your intercepts. It should make sense. Vertex form gives you your vertex. Intercept form will give you your intercepts. When you have these two values, you know that you can plot them on the x-axis. You might still need to do a little bit more work for the rest of the parabola. Now the very last form that's not typed out here is kind of a boring one, and that's called standard form. So we have standard form, and you've guessed it, it's pretty much just y equals, and then it's ax squared plus bx plus c. So that's standard form, and from here, it also, you can find your vertex, your axis of symmetry, and your zeros. Now when you're looking at your standard form, we can actually also find our y-intercept. So when you have a problem in standard form, you can find your y-intercept, and that's going to be c. You can find your axis of symmetry. You know, we shorten it to AOS. And that would be, you would write it as x equals negative b over 2a, and you just plug in your values for a and b. Now your vertex, we've again talked about this many times, that we know that our axis of symmetry and our vertex, they share the same x value. So what you need to do is you plug axis of symmetry in for x and solve for y. Okay, and when we do that, you'll find that you're going to get an xy point, and that's going to be your vertex. Alright, so let's go through all of the different methods and actually graphing them. So first off, you can see that we have a standard form equation here. That's because you don't see any grouping, you don't see any parentheses, it's just an ax squared plus bx plus c. So the first thing I'd like to find is the y-intercept. The y-intercept is the easiest. It's the constant term. So our y-intercept is going to be negative 2. Let's find our axis of symmetry. So we can use our little equation, x equals negative b over 2a. When we plug this in, it's going to be negative 2 over 2 times 1. So that ends up being a positive 2 over 2, which is 1. So our axis of symmetry is at the line, x equals 1. Now we can use our vertex to find, we can use our axis of symmetry to find our vertex. And we find that by just plugging it in. So we're going to plug it in for our x's. So y equals, we have 1 squared minus 2 times 1 minus 2. And just use your order of operations. So square that term, multiply, write it down. So we have 1 minus 2, which is negative 1. Minus 2 is negative 3. So our vertex, we know that the x is 1 and the y is negative 3. So we take these values and we put them on our graph, and we put them on our graph one at a time. So let's start with our y-intercept. It's negative 2. Now we have our axis of symmetry, that's at 1. So I'm going to use a dotted line at 1 to write and to kind of like give myself an idea of where it's going to be reflecting over. It's kind of like that mirror. Then next we have our vertex, and our vertex is at 1, -3. So we go over to 1, down to -3. Again, if your vertex is not on your axis of symmetry, something went wrong. You need to double check your work. Now, when we need to finish this out, we know that this is definitely not a parabola right now. I have 2 points in a dotted line. What you need to remember is that dotted line is your mirror. So anything you have on one side, you'll also have on the other. So that 1 point, my y-intercept was 1 to the left. So I'm going to put another one 1 to the right. And maybe I want 1 more point to find this out. So we do find additional points. And generally, you only need to find maybe 1 or 2 of these. So since I already had a point at 0, I'm going to plug in -1. I'm going to continue on this left side. And I'm going to see when I plug in -1, where's my point going to be? So I'm going to plug in -1 to my function. I'm going to do this in function notation just to show you how life looks a little different sometimes. So I'm going to plug in -1. When I plug in -1, I do -1 squared minus 2 times -1 minus 2, which is 1 plus 2 minus 2. So that gives me just 1. So I have an additional point. This is just a random point, and it's at -1, 1. So go to -1, up to 1, and there you go. I don't need to do any math to find the additional point on the right-hand side. I can see that if this point is 2 blocks away, I'm going to go 2 blocks away, and that's going to be my point on the opposite side. The best thing about the axis of symmetry is that it cuts your work in half. So when you're done, and I would say at least 5 points like how we have here, connect it with a U shape, and you're good to go. Okay, so now we're going to be graphing, and you can see that this form is a little bit different. Okay, when we're in this form, you can see that I don't even really see a squared term. Okay, I really only see an x plus 2 times an x minus 2. Now, from what we've learned last week, we know that we could FOIL this and it will be squared. So I know that this is going to be quadratic. So if we remember how our intercept form looks, we have x plus 2 times x minus 2. So the way that our form looks, it's usually x minus p times x minus p. Oh, sorry, q. Can't p twice. Okay, so now that I know that that's what it's mimicking, that's kind of like what I'm looking for. I know that my p is going to be -2, and that's because I saw a +2. If you plug that -2 in, it becomes +2. Our q is going to be just 2, right? Because I see a -2. It's a little confusing with the signs, but just take your time and be really aware of the negative signs. So I know I could get started, and I have 2 intercepts. One is at 2, and the other is at -2. So the best thing to remember when it's in intercept form, your axis of symmetry, is when you add these 2 numbers together and divide by 2, it's in the middle of your 2 intercepts. So what you need to do is you're going to do x equals p plus q over 2. So we end up with -2 plus 2 over 2, which is 0 over 2, and 0 divided by any number on the planet is 0. So our axis of symmetry is at 0. I'm going to draw a dotted line. Now this one is pretty clear to see that 0 is in the middle, but sometimes when the numbers aren't so even or nice, it is a little bit more challenging. The last thing we need to do is find our vertex. And it's still the same as every other time. Your axis of symmetry is the same x value of your vertex. So we're going to plug that in and find y. So we're going to have 0 plus 2 times 0 minus 2, which is really just 2 times -2, which is -4. So my vertex I plugged in 0, and my output was -4. Now you could find more additional points for this one just by plugging in a number either to the right or to the left of one of your points. This looks fairly spread out and nice and easy to connect for us, so I'm just going to connect it, and this is good to go. And lastly, we have one in Vertex Form. So when you're in Vertex Form, you can see that, I'll write the Vertex Form again over here. You have a value in the front, x minus h squared plus k. Alright, so for us, our problem is x minus 3 squared plus 2. Now this lets us see that in place of h, we only have a 3. It's not a -3 because our original form already had a minus sign. So 3 replaced h and 2 replaced k. Your vertex, that is hk. So your vertex is going to be 3, 2. Your axis of symmetry, and we know that our axis of symmetry is the same x value as our vertex. Easy as pie, it's going to be 3. We can get these on our graph, so we're going to draw our axis of symmetry at 3. Okay, dotted lines are always great. They let you know that it's not really part of your solution, but you need it to find your solution. Our vertex is at 3, 2, so we go over 3 up to 2. Now we can think back to that positive and negative idea. This is a positive parabola, so it will be going upwards. We just need a few more points. So this is where the additional points come into play. So we're going to find additional points. So I'm just going to plug in one number to the left. Okay, so I'm going to plug in, let's see, we'll plug in 2. So we're going to find f of 2. When I plug that in, I have 2 minus 3 squared plus 2. So it's going to be -1 squared plus 2, which becomes 1 plus 2, which is 3. So I'm going to have a point at 2, 3. And then I'm going to find another point on the left-hand side. And this time I'll plug in 0. We'll give a little more space. So I have 0 minus 3 squared plus 2. Oh, of course, this one's not going to fit. Let's see. So we have -3 squared plus 2, which is 9 plus 2, which is 11. So it's actually just a little bit above my graph. It's like right here in the arrow. That's the point 0, 11. And this was the point 2, 3. All right, so clearly this does not look like a U shape yet. This is where we go with that mirroring. If this was one point to the left, we're going to put it one block to the right. There's another point on our parabola. Remember, your dotted line is your mirror. Up here, this one is 1, 2, 3 blocks to the left, so we're going to go 1, 2, 3 blocks to the right. Once you have that, you know that you can connect this with a U shape. And you are good to go. Lastly, this problem is for you to try. So it's going to pause here. You can write this down and work on it on a piece of paper. Edpuzzle is going to ask you a few questions about it. And then once you're done answering that question, it'll show you the correct answer. Okay, so hopefully on Edpuzzle you've had time to answer the questions and you can check your work here. So you can see that your y-intercept is -3, your axis of symmetry is -2. When you plug that in, you get your vertex, which is -2, 1. You can find some additional points. So for instance, I only plugged in 1 and 1 gave me the point 1, -8, and I mirrored it over the axis of symmetry.